forensics. Okay, our next one is going to be, wait a second. I was on this network forensics, yep. Now we're going to be doing cloud forensics challenges, right? AWS, AWS, Azure. And I don't know why they didn't add GCP on there, but maybe just to save space for that title, right? But it might have GCP on that as well. So let's go find the next part of this, which is going to be AWS. So this is our next one, AWS Azure Investigation. I don't know why they don't have Google Cloud Platform on there, but maybe this is just specific to AWS and Azure, right? They don't really talk about forensics for Google Cloud Platform, but you do need to know AWS and Azure, right? Hello everybody, welcome back. This is going to be our video on, our YouTube video on cloud forensics challenges, right? We have AWS and Azure Investigation. For some reason, I did not include GCP on here, Google Cloud Platform. So this is going to be our cloud forensics challenges, right? We will look at like the complexities of investigating certain security events, right? And these cloud environments that may happen, because cyber attacks, believe it or not, can happen in the cloud as well. So we have to figure out ways to protect against that as well. So it might come up on the test, I have no idea, but it's still very important to know for real world skills, right? But it does include Google Cloud Platform, right? What is cloud forensics? Cloud forensics is the process of collecting, analyzing, and preserving digital evidence from cloud-based systems, such as those hosted on Amazon Web Services, AWS, Microsoft, Azure, or Google Cloud Platform. It involves investigating virtual machines, storage buckets, logs, and other cloud resources to identify evidence of cyber attacks or misuse. Why is cloud forensics important? Cloud adoption. Most organizations use cloud services for critical data and applications. Attack surface. Cloud misconfigurations, stolen credentials, and insider threats are a common risk. Incident response. Cloud forensics help reconstruct incidents and support legal investigations. Key concepts in cloud forensics. Shared responsibility model. All clouds are supposed to have a shared responsibility model. I don't think they ever put all of the responsibility on the customer. They always have a little bit of responsibility, right? So we have AWS and Azure secure the infrastructure, while customers secure their data and configurations, right? They're in charge of the building out their own systems that we would connect to, right? But the customer is in charge of making those secure, making sure they can secure their data. If their data gets leaked or anything, it's the customer's fault. It's not the AWS or Azure or Google Cloud Platform's fault, which I don't know if Google Cloud Platform really goes into all that, because I haven't really went into Google Cloud and learned all that stuff. But I know AWS and Azure most definitely let you build out that data and configurations, whether it be with those storage buckets or just the other storage methods, right? We have data, so just remember, right, that they're going to expect you to secure your data and make sure your environment's secure that you're setting up. But they'll be making sure that on their side that everything's secure and no breaches and stuff like that will happen on their side, while you have to make sure that no breaches will happen on your side, right? Or vulnerabilities or anything like that. They'll be more looking at the vulnerabilities of how, if their platform got hacked, right, you'd be looking at if your data got stolen, stuff like that. Data types, we have logs. AWS uses CloudTrail. Azure uses activity logs. Virtual machine snapshots and storage artifacts. We have acquisition challenges. Unlike on-premises systems, you can't physically access cloud servers, right? You can't physically go and fix something, right? So that would be part of the cloud provider's responsibility in getting you access to what you actually paid for, right? Jurisdiction. Cloud data may span multiple countries, complicating legal access. Major challenges in cloud forensics. Cloud environments introduce unique obstacles. Here are the key challenges. Limited access to data. Issue. Cloud providers restrict access to physical hardware and low-level data memory dumps, right? Impact. Investigators rely on providers' APIs or logs, which may lack granular details. Example, in AWS, you can't directly access EC2 instance memory, you must rely on snapshots or CloudTrail logs. So you can't do that memory dumping with AWS's memory, right? I think that's what they're saying, right? You cannot do dumps on their RAM, right? Because it's just virtual. It's memory that AWS owns, so you're not allowed to do any memory dumping stuff like that, I believe. Data volatility, cloud resources, we have ephemeral storage, auto-scaling instances are transient and may be deleted automatically, right? They could just go in and delete your cloud instance at any time, but they have rights to do all that, right? You sign like a customer agreement form or terms of service, and if you don't read it, it might just have something saying, oh, we can delete your thing and you cannot do anything against us, stuff like that. We have mitigation, right? No, think about impact. Evidence can disappear before it's collected. That is a big no-no for me, right? I would prefer to keep all my stuff on premises than to outsource my logs to the cloud, right? I could see if you're sending the logs to your on-premises server from the cloud because you have like Docker containers in the cloud, stuff like that, but not just using cloud as your only backup. And that's where people make a lot of their mistakes, right? They don't have backups. They don't have multiple backups. So like I'd use an on-prem backup, right? That connects to my cloud server, and it would send all of those logs over to an on-prem server that it's connected to through a VPN, right? I'd think it would be like a VPN, right? But VPNs have limited bandwidth, so there's better ways to do it, right? I could use, I don't know what I would use to get those files, those log files, and back them up, but you could do like a backup solution where you back them up to your on-prem server. So even if they did delete that, you didn't really lose anything because all your logs are still on your on-prem systems, right? Because you send them back. I don't know exactly how you would set all that up right now, but that's just a way to prevent that. There's other ways to prevent it, but if your thing just disappears, you have to have a backup, right? You get that backup by having multiple backups by sending them back to yourself, right? So that it's just not in one place, it's just not in the cloud. So when it does get deleted, it was still sent to somewhere else, right? Mitigation, enable logging. AWS CloudTrail, Azure monitor, and take snapshots of instances immediately. So that's what they're saying that they would use to mitigate it. Enable logging, AWS CloudTrail, Azure monitor, and take snapshots. So they're saying that they'd use AWS CloudTrail versus I was saying maybe you could do like an on-prem where it backs it up to your on-prem server, but you'd have to be connected to Amazon EC2 on your network, and that could introduce vulnerabilities, right? Encryption. Cloud data is often encrypted at rest and in transit, requiring keys for access. Impact. Without customer managed keys, investigators may be unable to decrypt critical evidence. Example. AWS S3 buckets with server-side encryption require keys accessed via AWS and key management systems. Issue. With multi-tenancy, right? Cloud environments host multiple customer or shared infrastructure. Impact. Isolating one customer's data without violating others' privacy rights is complex. Providers like Azure may limit log access to protect co-tenants. So they could just outright make it so your logs aren't available. And that's why the on-prem solution that I was thinking about could be a good idea if they allowed you, if you sort of found a way to do it, right? To actually send the logs back. For jurisdictional issues, you have cloud data may reside in data centers across different countries. Impact. Legal frameworks vary, complicating evidence collection and admissibility. Mitigation. Work with legal teams to navigate international regulations. Dependency on providers. Issue. Investigators rely on cloud providers for logs, snapshots, or metadata. So if any of those cloud providers lost their service, they wouldn't have access to any of their logs. They wouldn't be able to see anything. So that would be very, very bad, right? Unless they had backups and stuff like that that they collected before the servers went off. The AWS stopped working, right? The services went off. Impact. You have delays or incomplete data from providers can hinder investigations. Example, AWS may take time to provide CloudTrail logs in response to a request. Tools for AWS forensics. Here are key tools and services. For investigating incidents in AWS and Azure, we have AWS Forensic Tools, AWS CloudTrail, logs, API calls, and user activity across AWS services. Key features: tracks actions like IAM changes, S3 bucket access or EC2 instance launches, stores logs in S3 for analysis. Example, query CloudTrail for unauthorized EC2 terminations. So they have AWS CloudTrail. So they have the AWS command, right? They look up the events and they use lookup attributes. They look up the attribute key event name and then the attribute value of terminated instances. So you could figure out why your server why your virtual machines were terminated. An EC2 instance is basically just a virtual machine that you can connect to through AWS, right? Or SSH, stuff like that. Why use it? Essential for tracking user and API activity. Amazon S3 and Athena. Overview: S3 stores logs and Athena queries them using SQL. Key features: analyzes CloudTrail or VPC flow logs for suspicious patterns. Example, use Athena to query S3 access logs for unauthorized downloads. AWS Security Hub. Overview: centralizes security findings from AWS services. Key features: aggregates alerts from GuardDuty, Inspector, and CloudTrail. Why use it? It simplifies incident analysis across AWS resources. Azure Forensics Tools. Azure Activity Logs Overview records management planes activities. Virtual machine creation role assignments. AZ Monitor. Activity log list resource group. My resource group. Why use it? Critical for auditing and administrative actions. Azure Sentinel is different, right? We have overview: a cloud-native SIEM for threat detection. Azure Sentinel is a SIEM that is used for threat detection. And I could kind of see it looking sort of like WASA because WASA is also for threat detection and compliance. I don't know if this one is for compliance, right? But WASA is actually free. Key features: correlates logs from Azure services and third-party tools. Uses KQL custom query language for advanced analysis. Example, query Sentinel for failed login attempts. Sign-in logs where result type is equal to exclamation mark equals 0, right? Why use it? Powerful for threat hunting and incident correlation. Azure Monitor overview collects and analyzes performance and diagnostic logs. Key features: monitors VM metrics, storage access, and network traffic. Why use it? Provides real-time insights into resource activity. Third-party tools, we have Magnet, Axiom, extracts and analyzes cloud data from AWS and Azure. These are all mobile tools right here, but it looks like Magnet, Axiom can actually analyze cloud data from AWS and Azure. That was the key feature that we talked about in mobile device forensics, about how it could analyze cloud data, like even iCloud data, I believe, and GCP data, right? But it can also analyze cloud data from AWS and Azure, which is big. Oxygen Forensics supports cloud artifact extractions, including backups and logs. Oxygen Forensics can also be used for mobile devices, but the one that is mostly used for mobile devices is Celebrate, UFED, and UEFD Cloud, which I assume is just their cloud version, right? Analyzes cloud-based accounts linked to mobile devices. Key artifacts to investigate. Focus on these artifacts in AWS and Azure. Logs, CloudTrail, AWS or activity logs. Also, network traffic, virtual private cloud flow logs from AWS or Network Watcher. Azure for suspicious connections. Storage access, S3 buckets logs. AWS or blob storage logs. Azure for unauthorized access. Instance snapshots, we have EC2 snapshots for AWS or VM disk. Azure for system state analysis. IAM policies, which is identity access management policies. Check for overly permissive roles or unauthorized changes. Best practices for cloud forensics, we have enable comprehensive logging, turn on CloudTrail, virtual private cloud flow logs or Azure activity logs before an incident. Preserve evidence, take snapshots or instances, and export logs to secure storage. Use automation, leverage AWS Lambda or Azure automation for real-time evidence collection. Understand the shared responsibility model. Know what data you can access versus what the provider controls. Document everything. Maintain a chain of custody for legal defensibility. Practical example: investigating an AWS incident. We have Here's a basic workflow for investigating a suspected S3 data breach. We have the lookup event, lookup attributes, the resource type, the attribute values, and the name of like the S3 bucket and stuff, right? Identify who accessed the S3 bucket and when. Analyze the S3 access logs. Use Athena to query bucket access logs for unusual downloads. Review identity access management policies. AWS IAM get policy -- policy ARN. Then you do like the account ID, stuff like that. The policy name, the account ID, the policy name, and then you should be able to get in, right? After you log in and do some stuff. Check for overly permissive permissions. That's saying, oh, these permissions are too broad, stuff like that. Broad permissions are never good, right? Correlate with guard duty. Review findings for related malware or unauthorized IPs. Document findings, record timestamp user IDs, and access resources for reporting. CySA Plus. Exam tips for the CompTIA CySA Plus exam. Understand the shared responsibility model and its impact on forensics. Know key AWS and Azure services, CloudTrail, Centio, and their forensic uses. Be familiar with challenges like encryption and data volatility. Explain how cloud forensics integrates with incident response. Practice querying logs, CrowdTrail, or activity logs to identify suspicious activity. Conclusion: cloud forensics is a critical yet challenging aspect of cybersecurity, especially in AWS and Azure environments. By understanding the tools, artifacts, and best practices we discussed, you can effectively investigate cloud-based incidents. For the CySA Plus, focus on the unique challenges of cloud forensics and how to leverage provider-specific tools. Thank you everybody for watching. That is going to be it for cloud forensics with AWS and Azure and somewhat of GCP, right? So thank you everybody for watching the